All right, good morning, everybody. Thank you for joining. We're looking forward to a live demonstration today. Chris is going to take us through our hyperconverged infrastructure platform that we call UIS, and he's going to show us a couple of things that you can see it working live. This is running in our lab in South Africa, so this should be interesting. Thank you, Chris.
Oh, thanks everybody. Thanks for taking the time to join us this morning. We appreciate it. I thought I thought last night when I spoke to Mark, we're not going to do any slides today. I want to take this time to give you a little bit more of an in-depth view of, first of all, a little bit about the hardware that we have available for UIS, for hyperconverged, and then on top of that, the actual stack that we use, the software stack that we use on it. So we have a new version of UIS that we are running at the moment, with a new one dropping soon as well, another one upgrade. We're sitting on version 8 at the moment, and there's a few things that came along with version 8 over version 7 that made it a lot more budget friendly, first of all, and second of all, a lot more functionality, especially when it comes to integrating into VMware and with the challenges that we have with VMware as well. So this product slots very nicely into that. So first of all, on the screen you'll see an animation of a device which is our UIS 2000 device. Now, what you see there is a 2U device, a 2U chassis, so to speak, with two separate 1U compute nodes in it. So we have a top node and a bottom node. And I think if we look at that picture, that's the one, yeah. If you look at that picture, you can see that there's a top and a bottom node. In the front, we've got 12 hard drives that is shared between the two. Oh, sorry, not shared between the two, mapped between the two. So the left 6 drives is mapped to the top half, and the right 6 drives is mapped to the bottom half. So what you have here is a very nice, dense solution for running a hyperconverged solution on it. Now, in our previous versions of hyperconverged version 7, we didn't support a 2-node cluster. We only supported 3-node clusters, which meant that we would have to put another node into this. And, and obviously, with that came extra costs. Now, the good news is that with this new version of UIS, we actually support 2-node clusters, and you can just point the quorum or the witness node to a separate device, which can be a switch or anything, as long as it can actually just pin it. So this is very cool, because this basically makes for what we can now call a HCI appliance. So we can then go to a customer and install one device like this one, and basically have a on-site appliance with the software running on top of it. Now, this does not limit you to scale, because we scale using high-speed Ethernet. We can start stacking these on top of each other and create a 4-node, 6-node, 8-node, 10-node cluster, or you can just keep on adding to it. It also doesn't stop you from adding other 2U or 1U servers to it. You can do that also, right? So a lot of flexibility when it comes to stacking these on top of each other, and scaling out, making sure we add resources exactly where those resources are needed. So without further ado, we can reference back to this again a little bit later. We can now log into the UIS dashboard itself. Now, from the onset, when you look at the dashboard, everything is organized extremely well. And this is something that we have been getting feedback from a lot of our customers that's actually worked with us or have seen this, is that the way that the layout is done and the way that we manage these things are extremely intuitive. And I think, from an overview perspective, if you just glance at it at one go, all the information that you need is readily right there. We can see the amount of CPU cores that is available in the machine. We can see how many of those are used and how many of those are allocated. Now, because we support CPU and memory over commit, we can allocate a lot more than we actually use. So, which leads to densities that we get on this hardware that could be 5, 6, 7, 9 to 1, where we've seen on CPU. So, very good density. And if you think that you are doing 160 cores and a terabyte of memory in a 2U device, one 2U device consisting of 2 nodes, that is a very nice and a very well-positioned package for a smaller SMB style customer that's looking for a turnkey solution in terms of getting a hyperconverged solution up and running. So we can see the amount of memory, and we can see the amount of storage pools. Now, something to note with regards to the storage, we will get into that slightly in deeper a little bit later, is remember that part of our UIS solution, or the HCI, is our storage software called OneStore. So OneStore takes command of all the hard drives in this system. We don't create any arrays on the onboard array controllers. We let OneStore take care of that. So all the drives have been pooled together in this instance, and that consists of spinning SATA drives and some NVMe drives. But we don't carve those up. We gave OneStore the entire lot, and it is managing a caching layer, and it's then managing a data layer, and it's all done automatically. So you don't have to worry about how much you need for cache and how much you need for data. OneStore will do that for you, all of it. So very easy to deploy, very simple to manage, and extremely fast. The performance we're getting through this box is quite impressive because of the fact that the caching layer is so well managed by the actual software. So we look at the VMs portion. Now we've got a few virtual machines running on this cluster at the moment, and as you can see, there's quite a bit of variety of things that we're running. There's some Ubuntu on here. I'm running Linux Mint on it. I'm running Tailscale, which is Debian, and some Windows. So we supported a huge amount of operating systems on this system. So let me give you an idea, because a lot of people have said to me, do you support, and they come up with some funny flavor of Windows or of Linux. We can very quickly show you what we actually support. So we have, for Windows, from a Windows support perspective, there's lines and lines of stuff. I'm talking all the way back to XP and Vista. God forbid anybody uses Vista today, but yeah, okay. If that's your speed, then so be it, right? So a massive amount of Windows that we support, all the way up to Windows Server 25, which is the latest version of Windows. When we get to Linux, that list really grows. Okay, pretty much all the Red Hats you can dream of is in here. I'm going to go scroll through it slowly, but as you can see, then we've got even Novell older versions of Novell SUSE. And then we've got SUSE itself. CentOS is also part of that. Debian is part of it. Red Flag, this is a version of Linux that's used in the Greater Asia area, which is more for Chinese-speaking people and so on. Deepfin, Oracle Linux, Ubuntu, Fedora, some stuff you've never heard of also. Shine these. It even supports Rocky Linux, which is coming out of China at the moment. They use that as a base version for pretty much anything because of the way that it installs. So, I mean, whatever you can think of really is in here. Slackware is in here, the whole bag shit. And we also have BSD. Now, why BSD? Because I've had a few people that said to me, do you support SCO Linux? Now, if you know what SCO Linux is, then you're giving away your age, really, okay? Because this is probably the oldest version of Linux that we have, that we use and that we know of. It was used when it was still Unix. There was no real Linux at that point in time. So yes, we do support SCO, and there's not many vendors that actually does support SCO at this level. So a very nice differentiator when we start talking to our customers from the variety perspective of what we can actually support on these systems. Okay, so I'm just going to close this. Okay, so if you look at the setup of what we have here, you can see there's a CDK node there and a CDK node over here. So we've got two nodes in this cluster, and this is built on that UIS 2000 I showed you guys earlier, right? So you've seen a representation of the hardware, and now you can see a representation of the software that's on top of the hardware in order to give us that turnkey solution. So one device that we can put down there. Now, if we look at a host, we can do multiple things from the onset. You can add more virtual machines, deploy OVF templates. If you do have a OVF template like a virtual appliance that you want to come and deploy, it's as simple as just clicking on that. Sorry about that. Uploading the OVF file, following the basic steps, connecting it to the network, and then you're off, and it's done. So very simple, very, very, very intuitive. Okay. If we click on the display the host info, it gives us a breakdown of exactly the virtual machines that is sitting on that host. Gives you a very quick overview of your resource monitoring and the resources that is available and in use. Currently, we can see that there's about 9% of the compute resources has been used, and these little dials is actually a very good and quick indication of the overview. On the left-hand side, gives us a breakdown of the actual hardware that is in that cluster or in that host, right? So tells us it's a UIS 2000, tells us that there's two CPUs in there, the amount of memory, the free memory, the version that we are running, the virtual machines that's on it, storage, everything in a quick overview. And the same will go for the second mode. Now, they are exactly the same. The load is slightly different because the VMs aren't exactly the same size. But if we enable DRS, the dynamic resource scheduler, then DRS will move these machines, from one node to another node in order to balance the load. But the balance difference is not big enough for DRS to do this. It will only start moving machines when there's a huge deficit on, one machine to another one. So at this point in time, because there's so much free resources, nothing will move by itself. What's also very cool to see is at the bottom, if you look at that, is the CPU overcommit. which is what we spoke about earlier, and the memory overcommit that we spoke about earlier. So this is the ability to overcommit the amount of memory in the virtual machines as it maps through to the physical memory. So these machines have got 0.5 terabytes worth of memory in it. We can put about 1.5 terabytes worth of virtual machines on it, providing that we are running the CAS tools in the virtual machines. Because the CAS tools is very important for us. If we look at a box, and you'll see there the CAS tools is running, okay? The CAS tools is extremely important to us because it enables the memory ballooning and the memory management, CPU management of these machines. It's the same as VMware tools. If you don't install VMware tools, then your machine gets slow and it starts utilizing memory that it shouldn't, and all those kind of things. The same happens for us on CAS tools. So this enables us to have the memory only in use by the operating system or the application at that point in time allocated, and the rest of it is available for other workloads. We typically, this machine has got, what's it got, 16 gigs of memory in it, I gave it, I think. And if you look at the memory usage, we're using 30% of that. If the tools were not loaded, we would be using 100%. Okay, so you would be missing out on 70% of that machine's memory that's actually free, that you could use for different things. So we install this on everything, and it is available for everything. There it's running on Windows. On this, it is running bare Linux. Tailscale is probably going to run Linux as well, which is Debian, and then this is a Ubuntu machine on Mark. So lots of different operating systems. We make sure we run the tools, and then we can manage the resources much, much, much better. Okay. If we go to the networks portion, now on the left-hand side here, you'll see that we've got a lot of stuff available to us now, right? So this is where we are, where we will set up our distributed vSwitches. So in VMware, you can set up a standard vSwitch, or you can set up a distributed vSwitch, which means the virtual switch is distributed across both your nodes. We do the same thing. If we set up a vSwitch on a node, on one specific node, then it will be a standard switch. But if we set it up at cluster level, like we are when we click on the networks portion, because this maps directly to the cluster level, then we set it up as a distributed vSwitch. To add a vSwitch is as simple as just following the steps. Okay, we give it a name, we give it a description, we tell it which services will be running over that vSwitch. Okay, so if we're going to be running storage over it, for instance, we've got an NFS share, or we've got some iSCSI that we want to run across a very fast link, then we can come and tell it that we'll run storage on it. As you can see, we can run multiple services on one vSwitch as well. So if we only want to run storage on it, then we select only storage. But if we want to run the storage and, for instance, our backup network over the same network, we can just select both of them. What that means is that we will then put both those kinds of traffic on the same interface. Because remember the way that hyperconverged, or any hypervisor for that matter, maps out its vSwitches, its virtual switches, it is by port. It is the actual port that you have on the network card. So if we're going to run two services over the same network card, then we're basically going to tell it we are going to do both of them. Yeah. So from a management perspective, the default one always has management on it. And service for us is what we call the production side. It's not a service from a services Windows or services perspective or so on. This is what we call production. So if we put that services load on it, it means it is the IP addresses of your production servers, and that's typically the ones that you'll be connecting to. Okay. So we will then give it VLAN ID if you want to, and give it an acceleration mode, and then we can select the hosts to allow me to do that. Now we'll select the hosts on top of which you would put that network, and then basically once you click on OK, it will create a switch for you like the one I've got here with the lag, and you'll see then the associated hosts are host 1 and host 2. So I've actually put that onto both of those hosts. So very, very simple. If we want to create port profiles, for instance, we want to run different VLANs on one host, then instead of having tagged every single VLAN, we could come in here and put a port profile and say the virtual port for virtual machine 1, 6, and 7 needs to be in the same group, and then we tag the group. That way, making the management of those networks so much easier. Okay, very, very simple, and a much easier way than having to move VLANs around all the time, because you can attach that profile that we create to a virtual machine, as you can see at the bottom here. So it doesn't matter where that virtual machine moves, it takes the profile of the port with it. So if we do it on a network vSwitch level like we do over here, and it moves from a machine from one node to another node that doesn't have the same network attached to it, we will lose connectivity because it moves into a separate VLAN. But if we use port profiles, that profile follows the machine. It doesn't matter where it ends up on, we will be able to get to the machine. All right, so you can see at this point there's no we haven't set up anything outside of the default. But yeah, also if you want to do it, it's a very simple thing. Giving it a name, giving it a description. If there's a ACL attached to it, you can do it here, and then boom, we tag the VLAN ID. Very, very, very simple. Okay. Network topology will give you a quick drawing of what it looks like at this point in time. It's a very simple network, not a lot to it. On the right-hand side, it will start mapping out the physical interfaces. This takes a little bit of time just to give you that information. We've got the block log. If there is anything that you need to block or that you have been blocking from a firewall perspective, we can come and look at it over here. We can actually add physical switches to this to the UIS or the HCI solution, which is quite cool, because that means that we can integrate into the management stack of that switch. Now, this touches on our ADDC and our Cloud OS solutions being able to automate networking across the entire platform. Okay, so if you click on it and you go to add, we can actually, there's a list of switches that we support right now, and these are typically our data center switches, and we can connect to that. Okay, so very, very cool. We take this a step further in our Cloud OS solution, which is an enhancement of what we see here with multi-tenancy, billing, and so forth. That list grows quite extensively because we can do the network management and network orchestration from one platform. Okay, from under advanced networking, we can do stuff like software-defined networking. This typically comes back to what we just discussed on Cloud OS as well. Microsegmentation, yes, we support microsegmentation. We can then have a edge firewall, one of our firewalls that basically becomes what we call a virtual gateway, and then we can microsegment a portion of Ethernet that always has a firewall policy attached to it. So therefore, making sure that any inter-networking traffic or inter-VM networking traffic is also either encrypted or it sits behind a firewall. And if I say firewall, I put it in inverted commas because it is a virtual firewall. All right. We look at the storage. Okay. And because this is now running on one store, we support block, we support file, and we support object storage. Okay, on the same array. In this case, we are running very simple. We are running some block storage because everything is running over iSCSI. But every single, and this is basically the dashboards of one store that we've pulled into UIS, made them look the same, make them work the same, and a very simple view of how the storage is actually laid out. So if we click on the dashboard, then we'll get an overview of exactly what is going on. It'll tell us that it is distributed storage. It'll give us the virtual IP, and that's a virtual IP of the storage cluster. All right. It'll tell us the fault domain is host-based and the available. We've got available 63 of the 65 terabytes that is available. Gives us a host, and then very cool, gives us a map of the actual drive. Okay. This here we can see the throughput from a one store perspective that is going through those devices. If we look at the disk pool, all the data that's associated with the actual disk pool will be there. Remember that we can create multiple disk pools. We can use, and if we do a manual setup on the hypervisor when it initially installs, and we install the one store component, we can tell it to group a few disks together and some other disks together. So although I said to you earlier that we are using this, just the default configuration and let one store's taking care of it, you can still manually break the disks into pools. So if you want to tier it, you've got a requirement for tiering all your NVMe drives into one fast tier for databases kind of things. And the second tier, you want to use some fast SATA SSD. And the third tier, you would like spinning disk. You can split them up into those tiers manually if you wish to do so. And then once you start provisioning your virtual machines, you will then just select the correct disk pool of what you want to create. Okay. The same goes for data pools. If we have different data pools, we can set up more than one data pool. You'll typically do this as well when you're running tiered storage with disk pools in order to make sure that the right data ends up on the right disks. Okay, the host will give us just a throughput of what comes from every single host, and then even down to the hard drives. Okay, which is really, really cool. So if you look at the hard drives in every single one of those, remember I told you earlier how they map also through to the front end of the UIS. Okay, so if you visualize that, you can actually start visualizing the disks. This gives us the highest and lowest disk usage of exactly which drive where has the most data associated. And as you can see right now, it's very well balanced, really, really well balanced. The system is doing a great job of managing itself at this point in time. Okay, and this is all done basically on a next year's go for it, kind of configuration. It took about half an hour for me to configure all of this. So when it comes to deploying the software, it is a very, very simple solution, very easy to deploy, very simple to understand. And I always say, if you can read the screen, you should be fine. Right? Okay, so lots of stuff we can do here. If we go to the rack management, this is where we can get really fancy. Start putting more racks down with more systems inside of the rack. Start linking them together. And get a representation of more than one rack. Node management, the exact same thing as what we've spoken about earlier. The beauty about this view is it gives us a representation of the disks that's associated with that node. Now, as you can see at the bottom here, F, G, and H is a disk pool that consists of hard drives, but it's cache. all right? And although it is SATA, they are actual SSD drives. So that is the cache layer that is being used by OneStore to give us the performance. And this was all set up by OneStore by itself. I didn't touch any of this. I just let it do its own thing. And then the other three disks that's in there are normal spinning disk SATA drives. And this is true for both the nodes. They look exactly the same. And as you can see, there's a slight difference in the top. So the way that that it's being balanced at this point in time is done extremely well. So this is very handy when you start adding more and more nodes. And you can see how the disks, how OneStore will then start moving from the data away from the two machines and add it to a third machine and balance the cluster accordingly. So this is always, these services are always running in the background. It's always there, always doing its thing, right? So very cool, just to give you an idea of that. When it comes to the disk pool management, this is typically where we can add more disk pools if we so wish. As you can see, the storage types that we have, we can add block storage, file storage, data pools, object, or more hard drive. So we do support file storage, NFS, if you want to just add NFS to it from a disk pool perspective. Very simple. Give it file storage. We can, at the end of the day, we'll give it a cache ratio if you wish to. And if you hover over the question mark, it'll tell you the amount of data disk supported by the cache disk. And you will then go through the process of adding that cache, that disk pool, and then that disk pool becomes a disk pool like any other disk pool you can cut up into data disks and basically start using. So we support a lot of external pools as well. Okay, so data pool management, the exact same thing. There we can see the data pool that we have right now. If I click there on edit, it can tell us the readable and writable copies. And because we use copies or duplicates as a redundancy strategy on OneStore, we can then select how many copies we actually want of the data, and it will keep a copy of that data on each hard drive then forever. So because this is a lab environment, we're not that worried about the redundancy. If we break things, we can just fix them again. I didn't worry about those for too much. We were more worried about the space constraints, right? So you can put your writable copies and your readable copies in here as well. Okay. When we get, that was all the storage management. When we get to the block storage and you want to manage the block storage, you can simply come and you can add some more block storage if you want to. We can look at the cluster group. This cluster client group is where we are in at the moment. If we connect to an external device, then we will create another storage host group and pull that device in there, come in here, and basically then add it. All very intuitive. And as you can see, there's not a lot of information that you need in order for these things to configure. It's very simple. There's not a lot of questions. If there is anything advanced you want to do, you can always come back later and edit the VM data or the block, and then basically add those advanced features in there. The device, the mapping management, very simple. We've got a host group. That's the stored host group I was talking about earlier, the default one that we created, and it's mapped to both the drive, both the hosts. Sometimes you want to create some storage that only is active to one host. Then you will map it directly to that one host and not the other one. Or you can have a cluster of maybe two more machines underneath here that needs to go to its own storage. It's a lot of flexibility. You get what I'm saying. Lots and lots of flexibility in the way that we can do this and the way that we can map this storage out. Recycle bin, very simple. If we have deleted some things, you don't have to, and you want to recover it, it will probably still be in recycle bin. Recycle bin is something that we as a service run in the background and clean out every so often as per policy. But if you went that little oops, shouldn't have done that, we can come and recover it in the policy. Yeah. All right. Quality of service policy management. If we want to assign a QoS to a specific storage device, for instance, your backups, if you would like to run your backups during the day, you would typically want to throttle that backup throughput to something that will not kill the production network. If you don't have the flexibility of having multiple Ethernet segments that can do that, we can come and assign a policy over here. Okay. And as you can see, the metric types we support is IOPS or by bandwidth. So very cool. We can come and throttle certain services during certain times or days or whatever the case may be. Okay. We go to file storage. Yep. Run the setup wizards. Yep, we've got wizards. Run the wizards. We can select where the node pool is going to be sitting. There's no interface connected to this at this point in time, but you can follow the wizard, configure the NAS, configure the users that will be able to go to that NAS device. Hit the verify button, click next, and off you go. Okay, so very simple in order to connect or turn some of the disks into a working interface solution. And all the stuff that's associated with file system, all of it is sitting here. So the file system we can create more users if you want to add more users to it. We do the snapshots there. We can browse the directories. We can carve out quotas, very cool as well, so that you don't have one user that is taking up all the space. Because you know how users are. You give them more space, they will typically basically take all of it, right? So very quick, very easy to come in and set that up as well. Object, the exact same thing. Okay, we click on the object storage. We'll be adding some object gateways to it. We select the redundancy way that we want to do. We can use replication. We want to use erasure coding. Or how do we want to do this? Which protocols we're going to run this across, and if we want to encrypt that. So very quick and easy to set up your I see I'm starting to run not run out of time, but we're running short of time. Set up your object storage. Something else that we support is that because we're running iSCSI on this node, okay, on these two nodes, we can now share that iSCSI storage that we have. We can share that externally. So if we have for instance, a CAS machine sitting somewhere, and we want to present some of this storage that's sitting in the UIS to our CAS machine, we can come here and we can set up that iSCSI pool, and we can create a storage policy that allows it to connect to the associated storage that we've actually given it. Okay, so I'm still busy with this because I reloaded the CAS machine 2 days ago, but I'll be setting this up and then we can demo this and I can show you how this is done. So not only is your UIS storage available to the UIS, we can actually make the UIS storage available to external clusters, external NFS, external iSCSI, or whichever way you actually want to do that. So very cool, very nice, very easy to set up as well. And it's very, very flexible when it comes to using your existing environments if needs be. If we go to hosts, this is what we saw earlier. We've got the 2 hosts over there. Gives you a quick overview of the 2 hosts. If we go to cluster management, this is typically where we configure the cluster. This is where we enable HA, for instance. We can do services network high availability, which means that we will split the services across multiple Ethernet segments. that if we have a failure on one, we typically have a cut over to the other one. So think of this as a lag, but running across two different paths. Okay, give you from a redundancy perspective. You want to set up DRS, you can come in here, we can set up DRS. I haven't set up DRS at this point in time on these machines yet, because we really didn't have any need for it. But very cool, very simple. You can switch that on, and then you can tell it the interval that it needs to go and check the system for balance, what do we want to measure, and then the relation between it. So you want to do the CPU or the memory, or you want to do the CPU and the memory. And then here you set the threshold. So if the CPU gets to 80% of one box, it will then start migrating virtual machines over to the other one. The same will go for the memory. Okay, and then we can actually set the traffic as well, how much traffic it can use. All right, so it's a really simple thing. Storage DRS works the same way. If you have a node with direct attached storage to it, and that node starts running out of storage, we can allow it to migrate to shared storage. Okay, it will not be able to migrate it to a different host's direct attached drives, because you will lose connection between the two unless you do a migration of the entire machine. So we then support that you can actually do that across the platform in order to balance out your storage. Very, very important as well. People they look at the CPU and their memory usage and see that that's not balanced, but they hardly ever look at the storage side of the solutions. Okay, affinity rules are very important, because affinity rules, we can write a rule to say this virtual machine needs to stay on this piece of hardware. There might be, and I've seen this with PBXs, there might be a dongle that's plugged into the machine, and that's an encryption dongle, or it has something that has direct attached I/O that connects to it, and it needs to stay on that machine. It cannot be moved from one to another one. We can come in here and create affinity rules. Okay, we can gather the virtual machines, so in other words, keep them on the same VM, which is also, sorry, on the same host, which comes in very handy when you've got 3-tier architectures that doesn't like the east-west traffic scenario. They would rather be on the same host and use in-memory networking for that. Then we can actually gather them, put them together. We can also distribute the virtual machines and say, never have this machine and that machine on the same host. Keep them apart for redundancy purposes, for instance. Or we can assign a VM to a host, as I mentioned earlier, which means this virtual machine must always stay on this host because of whatever reason you've got. Okay, and we can do this by groups as well. So we can come in here, set up a group of virtual machines, VM grouping or host grouping. So if we have, and this comes in very cool, if you've got a cluster of machines, but the clock cycles, for instance, of your hosts are not all the same. You have some host that's running at 3.2 gigahertz, and you've got other hosts that's running at 2 gigahertz. You can typically create a group of the 2 gigahertz CPU hosts and another group with your 3.4s, and then tell certain virtual machines to stay within that group. So if you have SQL servers where you typically would like more CPU cycles, keep them pinned to the group of machines with 3.4 gigahertz CPUs, and keep your web servers and all the other servers on the lower clock speed. So again, lots of flexibility that we can do here. Okay, these are tools that comes in extremely handy when you start growing these clusters into much larger clusters, and you need that flexibility to be able to manage it better. As I said earlier, if there is anything remote that you need to install on a USB key, like an encryption key or whatever the case may be, we can come and map. We can come and map it here. Okay. Application high availability. This is where, in VMware Enterprise Plus, you got a functionality was called FT, or fault tolerant, where you could put two virtual machines on two different hosts and keep them basically one active and the other one in very hot standby, and replicate between the two. And then when the application drops, cut over to the other virtual machine immediately. This is exactly what we do over here. So we can run a version of fault tolerance across two hosts with one virtual machine. But instead of watching the virtual machine from a virtual machine perspective, if it's up and down, we can actually look at the application inside to see if there is if that application is up and running. Look at a service or whatever the case may be. For this, we need to set up some monitoring policies. Okay, we can get really granular when it comes to this kind of stuff. Then if we go to external clusters, this is when we start connecting external things to it. This is typically where the migration would take place as well. If we look at VMware, you'll see that I've got a lab virtual center that is connected to it. Sorry, we need to do it like that. Okay. Here you can see we've got the lab virtual center that's connected to it. And the only thing I needed was the user to tell it that it is a vCenter resource, to tell it the port and the username and the password. The API that we run, it connects directly from our systems, which is CAS based, all the way through to VMware systems, will take care of all the rest. So it's very, very simple to add things into here. CAS, I had a survey here, which I actually deleted subsequently. If there is other UIS solutions that you want to connect to here, then it's a very simple adding it. You select which ones you've got, UIS resource, you give it a name, you give it the username, the management IP username, password, click on it, and it'll add it as well. So you can then start bringing all those external clusters and showing them under one central management spot, which really, really makes things easier, that you don't have to go console hopping from one to the other one. And
Christo. Sorry, Christo. I have a question. Are you able to do a live migration today from VMware to UIS? Would you be able to demonstrate that?
No, I can't do that today. Purely because the lab is set up right now for the lab virtual center and CAS to be able to do that. I can't share the two.
Okay, all right. So you could demo the migration from VMware to CAS if anyone wanted that, right?
Yes, that we can do.
Okay, all right. Then how hard is it to add more nodes to a HCI cluster? Because currently you've got that UIS 2000 G6, but what if somebody decides, okay, I need to add a couple of more nodes, and maybe not the UIS 2000, maybe just a full-on 4900 or like a 3000 or something?
Okay, so if it is a UIS solution, so in other words, it runs the same operating system as we are running right now on that specific host, then it is a case of adding another host, connect host. All right, and then we will select the host when it's up, and then we'll connect to that host and actually bring it in. There you'll see we've got to detect hosts as well. So any version of UIS software from version 7 all the way up to 9, if you hit that, will basically detect. And then you will select it and then click add to cluster.
How many nodes can we have in a cluster?
4,096.
Okay.
So there's no theoretical limit. We just had to put a number down. But yeah, these things can scale massively. The problem or the bottleneck will always be the connectivity portion is how do we actually connect all these things together. So we are confident from an H3C perspective, taking into consideration the massive amount of bandwidth we've got available to up to 800 gigs, that we can pretty much keep scaling this until we run out of money or power, one of the two.
So
We'll probably run out of electricity and money before we run out of scale.
So we could use Rocky-enabled switches, 25 gigs, 100 gigs, 400 gigs, 800 gigs, and have the same NICs in these machines, and then use that to connect to transmit data. So that would become almost like a HPC kind of performance running in a HCI solution, if you go that route.
Correct.
Okay. Sounds good.
Okay. I think we've got about 7 minutes or so. I quickly want to just run through the services portion just to give you an idea, and then we can give a few minutes if there is any questions. Over here we've got built-in functionalities for virtual machine backups. We can kick off a backup, write it to a different location or onto the same location, or whatever we want to do there. It's a very simple thing. Create a backup and off we go. You don't need any other software for this. There's no need for third-party software if you want to use our own backup solution. The CVM backup, that is very important, because the CVM is the management console that we see here, that we are running. And if you want to then, just make a backup of that if you do have a failure, and we need to recreate it back into that point in time, that we can restore the actual backup. So we can run a quick backup. But if you check on the right-hand side, this comes back to how intuitive the product is. It gives you a rundown of exactly what you should do, what you shouldn't do, the recovery tasks, which notes to take care of. It's all set out very, very nice, very, very cool. DRX, I want to take a second to talk about DRX. Now, DRX is something that is unique to H3C. There's no other vendor has DRX. DRX is the ability to stretch and shrink a virtual machine dynamically. So you take, for instance, your payroll server. Okay, your payroll server does nothing for 29 days of the month, and then for one day it hogs, and it's the boss. It takes charge. Okay, so what you can do with your DRX solution is to take virtual machines and to give them a DRX policy and say, okay, you're allowed to add another 16 gigs of memory to this machine. But when you're done with it, according to that policy, you take the 16 gigs of memory back again. Now, I want to set this up because this is really cool. I want to set this up so we can demo this maybe in the next session, because this functionality itself is extremely powerful when it comes to managing those resources dynamically. And this is something that customers are asking for more and more these days, is how do I give it and take away, but I need to be able to do this very, very quickly. And this is exactly where our DRX comes into. It also gives you the ability to run load balancers. So if we have a virtual machine that has load on it at 12 o'clock at night because of an upload, banks use batch processing or anything like that, we can actually support load balancers on here as well. So this is a very, very cool functionality. I actually want to do this and show you this as a bit of a cliffhanger, or maybe a bit of a teaser of what we can do going forward. But this is a subject we can definitely spend a little bit more time on and show you how DRX actually works. Okay. So as you can see, there's our heterogeneous migration. It's going to tell you that MoveSure is not installed, and that's 100% correct, because MoveSure is our third-party software that you install in order to bring in physical machines, bare metal machines, or other hypervisors machines. The heterogeneous migration tool to migrate from VMware into CAS or UIS is already installed. Okay, as some of you may have seen when I do a CAS demo, the CAS demo shows that very, very clearly. So there's no need for this to be installed. It's only if we want to run a external machine, like for instance, take a physical and create a virtual. We need that MoveShare software to be installed onto it. Yeah, there's a few other small things that we can look at. The log, this is more got to do with the logging. It's got to do with the operations groups, creating users and putting them into separate groups, telling them what they can and can't do. Stateful failovers, if we've got some clusters set up for that, we fail over from one cluster to another platform. You can see these two machines are set up in a stateful failover. So if one of them does fail, we can, swap the two roles around, make one a primary and the other one a backup.
Sorry, Christo, our time's almost up. I just want to see if there's any questions from the audience. Yeah, got a minute left. I'm not sure what everyone's time's like. If you still want to continue a bit, does anyone have any questions? You can just unblock your mic and ask loud.
Go for it, Joe.
Do you see potential use in some of your client bases for this, especially with VMware causing challenges in the market? We've got a huge amount of POCs that you're busy running currently on this. And there's a bunch of things that we do that the competitors out there aren't doing. And our platform has been in the works for more than a decade already, and some of the new upstarts haven't got anywhere near as what we do, if I remember correctly. Right? Any questions from anyone?
Yeah.
Nothing.
No questions means one of two things. It's either be very good or the people are all asleep.
All right. If there's no questions,
we
can wrap it. Yeah.
We can wrap it up.
Thank you so much, Christo. Appreciate it. This was very informative.
That was good.
As always, I'm very impressed by hyperconverged infrastructure, and our platform is very, very good. Every single time I see a demo, I learn something new from you. So good job. Excellent. Thank you so much. If there's no questions, I think we're going to call it then. Thanks, everybody. Thanks for attending. And our next session will be in 2 weeks. We're going to be talking about Rocky and DDC, our data center switching. We alluded to it slightly this morning. I'll post the link in the WhatsApp group a little bit later today for those who want to register. Thank you so much. And I hope everyone has an awesome weekend.